Back in business. Hello, world. Cramming in a little 90-minute dev session here on Thanksgiving morning because I got some downtime. And because I didn't get as far as I wanted to the last day or so. So let's put in some more. I was in the middle of following a YouTube tutorial to do scrolling backgrounds, so I'm going to continue doing that. Should be fairly quick. This is to do a background. I'm going to mute this guy. By the way, credit to the tutorial I'm following. I totally just Googled this. Quill18 Creates. Go check him out because I'm following his tutorial for a Starfield background parallax effect right now. And it looks pretty cool. So let's do it. So doing what he did, make a quad, put this follow UV script on there. Assign the material. Just sort of skipping through his video here instead of watching it in real time. Okay. Making the material self-lit. We've done all this. Tiling offset texture. Zeroed out. And I had set up a material for this. I might actually be done setting this up already. I never tested it last time I was working on it, but might be done with all the steps here. Here we go. Transform. He's got a basic ship mover. And he's got the starfield attached to the main camera. Okay. My main camera is not attached to my ship, it just follows it. So we'll see how this goes. Let's give it a test. Oh, look at that. Look at that depth. So now we have a background that follows the player. And does it at a different rate. And it creates this nice little depth illusion. You can't notice it when you're just moving really, but as soon as there's another object on the screen, like this asteroid, you can tell that there's this like depth illusion going on. This is beautiful. Thank you, Quill18 Creates. Go check out this channel. This was a sweet little short tutorial for a really powerful effect that I'm totally going to use. Oh look, and we found the edge of the texture, and therefore the edge of the universe. No, this is good. You can do this with like a looping texture, but I just have this placeholder nonsense for now. So yeah, this looks really sweet. And he says in his tutorial that if you want layers to your parallax so that it looks like there's close objects and far objects, you can just give them different parallax values. So I could have like planets that are really close and big, and then like a star field that's more distant with just different parallax values set on them. So this is pretty sweet. I'm gonna try messing with these parallax values and just see what it does real quick. I think it changes the rate at which the background scrolls, so it's gonna, yeah, if you set it super high, then the background is like super static and it makes it seem like it's super far away and you can't even tell you're moving. And then if you set it to like a very low value, okay, so yeah, if you set it to 1, then it just looks like it's glued to the wall, basically. Makes it look like it's very close to you and you're just flying around on it like it was static. And then if you set it to like a lowish value, makes it look slightly distant. So this is awesome. I'm actually going to rename his script though. What is the cleanest way to rename the script? Rename. Parallax follow background. I think that'll help me remember what this actually does later more than. Something with parallax in the name is going to remind me what this does. So background nebula, this is renamed. Let me just check that it's still working. Nice. Okay. Cool. Yeah, that depth illusion is really powerful. It suddenly set this to like 5. Yeah, so we travel a little bit on the background. You can see like the background is moving, but it's way, way slower than the things in the foreground. This is so sweet. I think I like this at like, I think I like it at about 5. I'm going to leave it there. All right. Let's decide what to work on next. So I got this little background effect. I was thinking about it, and I think I would like to experiment with different ways of controlling the ship that behave a little differently. Oh, hang on, my dog is losing his mind. I'm gonna refill my coffee and let my dog out. I think when I resume here, I want to experiment with a separate way of controlling the ship where it follows the mouse instead of this left-right kind of physics simulation approach, and sort of settle on which feels more fun for the game, and then go with that. So I'm gonna put maybe 30 minutes into one other movement approach, see which one feels better, and then go with it from there. So I'll be right back. All right, back. So yeah, I wanted to experiment with a different locomotion system for the ship, so I'm gonna do that. Let me... It's a raven here. So I was imagining doing... like a point and click movement system where you point with the mouse where you want to go and the ship will automatically rotate towards that point. And then when you hold down click, thrust towards it. It's more of a gamey way of moving and less of a simulation way of moving, because the way it works right now is I have this physics simulation where I have thrusters and they push you forwards and you rotate left and right like this. And if your thrusters are off balance, like you have too many on one side, they will start you rotating. Like if the weight of the ship is off center, you sort of spin, which is fun from a like shipbuilding perspective, because then parts of your ship can get blown up and it can knock you off balance and all that kind of stuff. However, it is much harder to control, so it makes for a very different type of gameplay. I'm going to experiment with this other movement method and then see which one I like better. So I don't want to drill down too much on doing like a completely different approach to controlling, so I'm going to do like a 30-minute prototype of this and then go with whichever one I like better. It could potentially have a big impact on the game, but I feel like I need to run this experiment. And my overall goal as far as like the timeline here on the 40-hour project is to get is for like the first 20 hours to be prototyping, where I'm making enemies and where I'm making like systems, basically some basic enemy AI, one level, and a bunch of different types of blocks for the ships, things like homing missiles and controls and all that stuff, until there's like a fun playable prototype. And then the latter half, the latter 20 hours, to be like content, like levels and menus and adding more pieces, more enemies, more variety, and kind of the game structure around that. So I'm going to spend about 30 minutes on another movement mechanic, and then the next 6 hours of dev time after that are going to be further systems prototyping, followed by 20 hours of like content, which will also include some sound, some menus, art, making sprites for everything so that it at least dev versions of like pixel art sprites for all of the ship parts and things like that, making it look half decent, or like there's been an actual attempt and not just solid colored geometric shapes. So that's kind of the plan. But first, I want to try this different locomotion here. So gameplay, I'm going to call it point click move. Where's my ship? Under gameplay. Okay. Let's do point click move. Is this compilation thing fixed? Seems like maybe it is. I was having that issue last time where every time I tabbed out and back from Unity, it was like compiling for longer and longer and longer. I don't know why that happens, but I did a reset and it seems to be better for now. It might be one of those problems that kind of accumulates. Ooh, that's interesting. Whatever, Visual Studio. Yeah, it might be like a problem that accumulates over the course of a session. Or like a one-off bug because something got stuck. I don't know. Seems better for now though, so I'll take it. So on update. No. First, we're going to need the ship's rigid body for this for sure, so. All right. So my thinking is every frame it's going to apply a rotational force towards the mouse, and also when it is within 90 degrees of the correct facing, it will start to thrust in the direction that the mouse is placed. And we can potentially scale that thrust so that if you like drag the mouse way out to the far corner of the screen, it'll go faster. If you put the mouse just in front of the ship, it'll go slower and try to kind of approach. So you can hold down right click and drag the mouse anywhere you want, and the ship will automatically try to go towards where the mouse is. That's my thinking anyway. So I'm going to give that a try. So I'm going to have two methods. One that applies the steering force to turn the ship in the direction of the mouse, and then a second method that will apply thrust in the direction of the mouse and have rules for when those get used and how they work. So I'm going to do apply rotation force and apply thrust. So first of all, this rotation force, we want it to turn towards the direction of the mouse. So I'm going to get first of all, every frame we need to get the mouse's position in world space. So we need to see where in the scene the user is pointing the mouse. And I did this earlier for the debug keys script. This. We do a raycast at the screen through the mouse point. Actually, we don't need to do a raycast, do we? This is going to work differently. Mouse world position is just going to equal, helps to spell camera right, camera.main dot screen to world point, viewport. I think it's screen to world point. Let me get an example of how this works. Camera.screen to world point. Here we go. This is the example from the Unity docs. This is too small. Mouse world position is going to be camera.main.screen to world point. It's going to take in the mouse X, the mouse Y, And I'm just going to call it 0 depth at all times, because the depth doesn't really matter. I'm going to print this out and see what it says. All right, let's test this. Not implemented. Oh, yep, left this here. Okay, it is printing out. Let me see if the value looks correct. Okay. 0, 0, right there. Yep. X increasing, X decreasing, Y increasing, Y decreasing. It's always at depth -1. So maybe... we do actually want that. Near clip plane setting, so that we end up at 0. I see. No, it's fine. I don't think we care about the clip plane here. I'm just gonna 0 it out manually. Okay. So the ship exists at depth 0. Cool. All right. So we're printing out the current mouse position. Next, I want to apply a rotation force so that the ship will slowly rotate towards that point. So what we're going to want is, if the point is to the right, we slowly rotate to the right. If the point's to the left, we slowly rotate to the left. And but we're also going to need kind of an approach behavior so that as we start to rotate to the correct orientation, we'll slow down. So we can't just always apply a force in the direction. We need to actually decelerate as we approach it. Which is called an approach behavior. And I want to look up an example of this. I've done this before, but I know there's good tutorials for this. Flocking. I know there's a good tutorial for this. Particle. Okay. Steering behaviors introduction. Okay. Looking at some tutorials here. Hold on. I'll move this to a new window. So we have a desired direction, and we normalize the desired direction and then multiply it by the max speed. So that's the direction we want to go at the maximum speed. So that's the velocity that we want. Then we will steer in that direction. And then what I'm looking for is an example of the arrival behavior. Arriving behavior, here we go. I see. Okay. This makes sense. Had to kind of wrap my head around how to implement this kind of thing. So we are going to have a desired rotation which is the facing that we want to adopt towards the target. And then we will have our current angular velocity. Let me see. Ship rigid body. Angular velocity, which is a float. Got it. It's a float because in 2D there's only one axis that we're rotating around. Okay, cool. So desired facing direction is going to be mouse world position minus my position okay, so the desired facing of the ship is going to be the position of the mouse minus the position of the ship normalized. So a vector pointing in the direction of the mouse is the way we want to face. How do we convert that into a vector 2 rotation? Let me test something real quick. So our ship has 0 rotation right now. And goes from positive 180 to negative 180. Okay. So I'm looking at this value here. When the ship is pointed straight up, it's at 0. So we're going to get the vector direction. So like if the mouse is up here, we're going to get that vector direction, and we're going to get the ship's current facing, and we're going to get how many degrees between the two that is. Transform.up. Make that a vector 2. So we just completely ignore the z. So we're going to have to convert the desired facing into a float that is how many degrees rotated around the z-axis we want to be. Plus angle. So let me see what this is printing out here. This should be printing out the angle in degrees of the direction that we want to face. Okay, so if we're pointed straight up, this is right now giving us 90. It's giving us 0 when it's to the right. Cool. Negative 90 over here. And here there's that flip from negative to positive 180. So, which we're going to have to address as well. So when the ship is at 0 rotation, it's giving us 90 right now. So we actually want to subtract 90 from this value so that up is our 0 degree equivalent. So now we can see it's printing out desired angle 0, negative 90, positive 90, negative 180. And is that the same? Turning to the right is negative 90. Yep, negative 90. Okay, so now we can convert the mouse position into the desired z rotation of the ship. And we can call this value desired z rotation. So that is the angle that we want the ship to have to face the mouse. And so now we need to see what direction do we need to be rotating to get there. So current facing direction, we can actually just do float current z rotation equals transform dot rotation dot Wheeler angles dot z. So we know which z rotation we want. We know what z rotation we currently have. And then the other value we want to get is current angular velocity This is how fast we are currently rotating. So if we're spinning hard one way or the other, that's going to be a big number. Our current angular velocity is equal to, we can grab this from the rigid body. So that's how fast we are currently spinning. And what we want to do is spin in the correct direction. So our desired angular velocity is so this is the fastest that we want to be able to turn the ship, and then steering force is how quickly we can accelerate our spin in a different direction. So we have all these values now. Just copying these down here as comments so that I can remember what they're called. So we know how we want to be rotated. We know how we're currently rotated. And we know our current angular velocity. And our goal is for our current angular velocity target angular velocity, how fast we want to be turning is we want to be turning at max speed towards the direction of rotation that we want. So that's going to be, we want to be going at max rotation speed in the desired rotation. So I think what we need to figure out is how many degrees do we need to rotate by to get to the direction we want. Minus so the degrees we want to rotate is the desired rotation minus our current rotation. So if our current rotation is 0 and we want 90, then we need to rotate 90 degrees, and that's what this value is going to be. The tricky bit is that when we hit negative 180, it flips to positive 180. And so what we're going to need to do is say, I think if something like this, where if we're trying to rotate more than 180 degrees, we need to subtract 180, and vice versa. This might be wrong. It's greater than 180, subtract. If it's less than 180, if it's less than negative 180, we need to add 180. No, we need to add 360. And if it's greater than 180, we need to subtract 360. Adding or subtracting 360 doesn't change the orientation, but it does put it into the range of degrees that we want. So let's print out how many degrees we need to rotate and see if it seems to be spitting out correct values for what we want. What is this complaining about? All right. Let's test this out. Need to assign a reference to the point click move. Okay, it needs a reference to the rigid body. All right. So if the ship is pointed up, which it is, and our mouse is right in front of it, it says degrees to rotate, basically 0, which is good. If this is over here, degrees to rotate -90. If this is over here, degrees to rotate +90. That's good. What happens as we get back here? +180, +180, -180, -180. Nice. This is actually spitting out the values I want. This looks good. So we know how many degrees we need to rotate to get to what we want. What if I flip the ship so that it's face down? Do the same thing. Degrees 0, negative, flips to positive. Nice. Okay. Cool, cool, cool. So now we need to apply forces. So we know how many degrees we need to rotate, and we know our current angular velocity, and we know our current angular velocity is the ship's angular velocity. And the desired angular velocity is going to be the maximum allowed angular velocity in the direction that we're supposed to rotate. So if we're rotating positive degrees, we want this to be positive. And if it's negative, if we're supposed to turn negative degrees, we want this to be negative. So our desired angular velocity is the number of degrees we want to rotate, whether that's positive or negative, times the max angular velocity. But then we need to clamp that to so that it's no larger than the maximum angular velocity. We need to clamp that value to something between positive and negative max angular velocity. So we can never be trying to go faster than the max angular velocity. So taking the degrees to rotate times the max angular velocity, clamping it to negative or positive max angular velocity, and then but if we're close to the right rotation, then we actually want to be going no faster than we want to slow down as we're approaching the correct rotation. So So we want to clamp this to within we want to clamp the desired angular velocity to somewhere between negative degrees to rotate, positive degrees to rotate, so that as we start to get close, this will slow down. So now we know our desired angular velocity, if I did this right, and we know our current angular velocity. So now we just need to apply the force. So this is going to be rigid body, ship rigid body, dot add torque, all right, so the torque we want to apply is the angular velocity we want minus the current angular velocity. My dog's being a lunatic. But we never want the torque to be more than the max. Call this max torque. Because it's really what it is. Clamp this value to between negative max torque, Okay. Let's try this. I did a lot of things, and there's a good chance I screwed something up here. But I'm going to give it a try and see what it does. Max torque. I really don't know what to set this value to. I'll just call it 10. And max angular velocity, we'll call it like 90 degrees per second, because I think this is in degrees per second. Maybe I'm wrong. All right. So this is not behaving currently. Object. I'm going to add a little triangle tip to the cockpit so that we can tell which way it's facing, because right now it's very hard to tell which way it's facing. Okay, and let's see what it's doing. So it is getting to the right rotation, it seems like. Kind of. But I think the torque is too high because it's like bouncing around like crazy. So let's say... Let's tune some of these values and see if it's actually misbehaving or if the values are just way off. So, where's our script? There we go. Set max torque to a really low value so that it turns very slowly. All right. It ended up pointing the right way, but it rotated in the wrong direction. Nice. It is pointing at the mouse, but if the mouse is on this side, it goes around the long way. So I tried to fix for that with that little positive negative check, because it's going around like almost 360 degrees to get to the correct rotation. So I need to look at why that's not happening correctly. I can look at the debug values on the script here, see what things are set to. I don't have those variables exposed, but that's okay. So this is turning to look in the right direction, which is good. It's really just that we want it to flip back the other way to when it's needed. So need to go address my dog because he's barking and run to the restroom. So this is pretty close. I'm going to debug it when I get back in a minute. BRB. Okay, back. So I'm always rotating the wrong way. Well, it's not that I'm always rotating the wrong way. It's that I go the right way if I'm rotating. What is this? If I'm rotating in the positive direction. If I'm supposed to rotate in the negative direction, it gets flipped around. So my desired angular velocity is flipped half the time. Desired z rotation minus current z rotation. Let's print out the degrees to rotate. See what we're getting. Degrees to rotate. It's positive, 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 and then when I pass behind, oh, it's flipping to negative. So it actually knows the correct direction to rotate in. It's just applying a force in the wrong direction. So degrees to rotate is correct. I kind of expected that to be the thing that was flipped. So the desired velocity print the desired velocity. Is that getting flipped? At some stage here, I'm getting my sign flipped. So everything's rotating the wrong way. Okay. All right, let's do the desired angular velocity. It's too much other spam. Okay, so that wants a small positive value until it catches up, which is nice. And then when I go this way, it gets to a very large positive value. The deceleration is working great. So the desired angular velocity never turns negative. Okay. So I've screwed up something in these two lines here. The desired angular velocity should be the amount of degrees we want to rotate times the max angular velocity, which is always a positive number, so that shouldn't change the sign, clamped to between negative and positive max angular velocity. Okay? Then we want to clamp it to... What if I just don't do this? Just let it go way too fast for a second. Okay, now it's turning negative. And it's actually doing what we want, it's just twitching. So when it reaches the correct rotation, it keeps trying to push a little bit back, a little bit back, a little bit back, and it never arrives at the correct rotation. It sort of fidgets because it's always applying the full force, and I'm not doing this clamping. So somewhere here, I'm screwing up the... clamp the desired angular velocity between negative degrees to rotate and positive degrees to rotate. Why would this line be changing the sign? That's what I'm confused about. Should be clamping this value to somewhere between a negative number and a positive number. Oh, maybe if this number is negative, is positive and this number is negative, it's doing some weirdness with flipping the sign. If the minimum value is larger than the maximum value, maybe it's flipping the sign. So... This is a very hacky way to check the sign, but I'm going to see if this works. So the lower of the two numbers, the higher of the two numbers. And look at that. It steers to face the mouse. Yeah, I had a weird sign problem where if it wanted to rotate by a negative number of degrees, it was flipping the sign of the number while trying to clamp the number. Okay, cool. So the ship now rotates to face the mouse, which is awesome. Exactly what we want, and I can tune the values a little bit for the torque force and all that. So let's turn off debug mode to clean up our view of our variables here. So I'm going to call max torque 2, max angular velocity, maybe like 180 or something. How about max torque 5? Oh, now we got twitching going. Too much torque. What if I set the max angular velocity really high and the torque really low? Cool. Two. It should still be doing the arrive behavior where it decelerates as it gets close. And it is not. Because it is twitching a little bit. When I set the torque value low, it doesn't twitch. It does subtle twitching. My dog is losing his mind out there. All right. Cool. So let's say max angular velocity is like 90, so we never do more than a quarter of a turn in a second. There's that twitchy torque. So we figure out our torque value. Desired angular velocity is being clamped to the amount of degrees to rotate. The twitching behavior should be clamping the desired angular velocity to... Oh, I see. Hold on. I'm also skipping a step here. I'm not scaling the torque with the amount of time that's passed this frame, so it's going to be stuttery with the frame rate. So that could account for stuttery behavior. You always want to scale physics effects with the frame rate. It's of course going to go a lot slower now. Nice. That's nice and smooth now. It's too slow, but it's smooth. I'll set this torque to like 30. How about 60? There we go. Now it's turning nice and fast. And when it hits its target, it no longer vibrates and twitches. So that was happening because the torque was constant, even though the frame rate wasn't. So from frame to frame, it was just twitching slightly while the forces were applied inconsistently relative to the passage of time. So nice. So, oh, I never updated my current task on the overlay, did I? Alternate ship controls. All right. So this feels really nice. And I think the main thing that needs to change here is needs to be a little snappier. What if this is like a huge number? Hey, how's it going? Doing good. Testing out a different locomotion method for the ship here. Thruster, thruster. Okay, so now I want to test actually pushing the ship in the direction of the mouse. And this will be quite a bit easier, especially because we're going to cheat it a little bit and have it Americano. Beautiful. Also an Americano. What's coding? Working on controls for a spaceship. So right now this is set up so that you can, let me turn this off real quick. I can demo sort of what I'm working on here. So you can kind of build and customize a spaceship by putting thrusters and things on it. And right now you control the ship by turning it with the arrow keys like this, or by thrusting it with the up and down arrow keys like this, which is all cool and fun, but it is very tricky to control because it gets spinning and then you end up in this kind of situation where you can't get it to go in the direction you want. And so I'm testing a control scheme where you just point with the mouse where you want the ship to go and it'll automatically rotate towards the mouse and push in that direction. And I'm going to see whether this like kind of more realistic physicsy key-based movement is more fun, or the just point and click with the mouse, because that gives you a lot more control. It's just a little bit less realistic, so it's less of a simulated space movement kind of thing and more of a gamey kind of way to move. So I'm going to see which one feels more fun, because it's very hard to, like, if you're going in a direction right now and you want to go back the other way, you got to like turn around and thrust back, and it's fun, but it is very hard to control because you can get spinning and get sliding and it's just hard to slow down, that type of thing. So testing out a control scheme where you just don't have to think as hard about it. Gonna see if the game feels better that way. Yeah, it's game coding. On this channel, we do lots of tabletop RPGs and stuff about board games. I am testing out, my day job is working on video games, so testing out streaming some of that as well by trying to code a game in a fixed time period. Trying to do this whole game from scratch in 40 hours, where kind of the first half of it is prototyping stuff like controls and movement and levels and enemies and weapons and a bunch of mechanics, and then the second half of the 40 hours is going to be spent on content, so making levels and power-ups and menus and art, all that kind of stuff. So right now I'm in the prototyping phase where I'm just trying to make the game fun, make it feel good, and build lots of systems and mechanics into it. Sup, bro? Welcome, Noodles. Here, you want to see me customize a ship? Thrusters. Put some guns on there. Should I go shoot an asteroid? Come here, asteroid. Wait for it, wait for it. Explosion. Game's basically done. Nice thrusters, bruh. Yeah, let me turn on an enemy here real quick. Boop. I've got a little turret enemy. Where is he? There he is. I'm sliding around way too fast. Hit the brakes. I really need brakes on this ship. Here, look. If the enemy shoots at you, does damage to your ship, and parts blow up. And if it blows up a part that other parts are connected to, well, if I can get it to. Come on, hit me. Hit me. What should I do it? I'm having too much trouble controlling my ship to get killed right now. Let me balance my ship and fly back real quick. Shoot me, bad guy. Where is he? He's down here in the middle somewhere. There he is. It's very hard to control this right now and to see where you are because there's not a lot of objects for context, so I'm just sort of sliding through space, losing track of where I am. Like you do in space. Come on, hit me. Come on. Trying to get my ship destroyed. There we go. See, if a chunk of the ship gets destroyed, then everything connected to it goes as well if it's not connected to the ship anymore. So it's automatically checking all that. And you can be left wounded and wonky. Nice. Artists for what type of art? Like 3D art, 2D art? I've been doing this, I mean, I've been doing it since college. I'm in my 30s. I did a few years of indie game development and then started doing Unity development at like a marketing company and then switched back to doing my own thing. You could say I've been doing this like 10 or 15 years. But it's been different versions of it and different applications. I've done some AR, VR stuff. Some other types of interactive software like interactive projection mapping, that kind of stuff. But maybe 10 or 15 years of working with game engines. I'm always looking for artists to work with, and I'm planning to do a game jam in January. If the type of art is a match. Rusters. Whoops. So yeah, I'm working on... And also Python and C++. Great stuff to learn. Because both of those... I mean, C++ is the best language to... One of the best languages to have an understanding of coding at a low level. Because it's powerful and it gives you control and it forces you to learn a lot of the hard fiddly lessons. And then Python is just so broadly applicable. This is all C# here, what you're seeing. This is all Unity engine C# development. Logos, social stuff. Neat. Yeah, for sure. You should comment or DM on Twitch or YouTube, wherever you're watching. Send me stuff. I'm always happy to network and meet new coders and artists. Get somebody on the Rolodex. And if I'm ever doing a project that seems like a good match, I'll badger everybody I know to try to find people to work with. So yeah, if you're coding in C++, this would be really easy by comparison. Yep, we have a Discord. We just set up a public Discord for this channel, which a lot of what's on it and a lot of what we do on the channel is tabletop RPGs and board games and stuff. But I have a chat channel on there for talking about game dev stuff. So look in the about page or the about page on Twitch or YouTube. Both have a link to the new public Discord. So you should come on there and say, hey. It's new. We just set up the Discord within the last like 2 weeks, so it doesn't have that many people on it yet. Just a small group. but it'll build up over time. So right, got a little more time, so I'm gonna finish trying to prototype this ship movement thing. So I have it set up so that the ship will automatically rotate towards the mouse, which is a good start. Did I turn it off? Max torque. I did turn it off. So I'm applying rotation force. I'm not yet applying thrust in the direction that I want the ship to go. So yeah, it'll be the Wanderers Guild on Twitch or YouTube. And on the Discord, I'm Scissors Lizard. Because that's my like individual handle I use for stuff. I have like a little red monster icon on there. So if you join the Discord, you'll spot me on there. And if you Discord the Wanderers, or if you message the Wanderers Guild on Twitch or YouTube, it'll go to me as well. Because I manage both of those channels. And I'll share things with the rest of the team if it's relevant too. Right, so max torque. My torque values got reset. Hate when my torque gets reset. 30, 60. I think I had this tuned to like 60 and 120 or something. That's not bad. Needs more. Needs more punch. Still feels a little floaty. I think I need to... What if I set these both super high? Yeah, this is clamping for some other reason. Oh, I know why. I have a hard-coded cap on rotation speed, I think, from the other movement method. Max angular velocity 120. Okay. I forgot I had this in here from forever ago. Set this super high. That didn't do what I expected. This still feels a little slow, the rotation, so something I did earlier I think is interfering with the rotation a bit, but that's okay. It works for now, so I'm just gonna finish testing it and then I can figure out what's going on and tune the values. So max angular velocity, let's call it 120. Max torque, we'll call it 90. No, 45. I'm Josh. Oh, I am DM Josh. I said I was Scissors Lizard and I'm not. I forgot I have a different name on the Discord. Yeah, I'm DM Josh on there. Okay, so we have rotation. Now we need to apply thrust in the direction of the mouse. And it's going to behave in a lot of the same ways. We're going to start by figuring out the desired position. This is where the ship is trying to get to. And that's going to be the mouse world position. We've got the current velocity equals, I'm sure I probably did. I can double check real quick. Pending. Got it. Yep, added you. So the velocity we want is to be max velocity and max thrust. Copy these down here. So the max velocity is the fastest our ship can go. The max thrust is how much force we can apply at any given time to accelerate. So let's check our velocity. Which is a vector 2. And then the desired velocity is what we want to figure out, is how fast do we want to be going and in what direction. Equals the mouse position minus the ship position so that's the direction that we're going in normalized. So this just gives us the direction times max velocity. So we want to be going at max speed towards our target. However, we want to clamp this velocity to, well, I'll get to that in a minute. We want to clamp the is there a built-in method to clamp? Yeah, clamp the magnitude. So what we're doing here is we want to say this is the speed we want to be going, max speed in the direction that we're going. But if we're very close to the target that we're trying to get to, we want to slow down so that we don't overshoot it. So the maximum speed that we're traveling needs to be we want to clamp our velocity to be the distance between us and the target, effectively. Which we're going to call arrival distance. So arrival distance is once we get within a certain bubble of the target we're trying to move to, we start to decelerate so that we don't overshoot it. So velocity for more space? I'm not sure what you're asking. Arrival distance. We'll say if our distance to the target desired position is a vector 3. Make this a vector 2. Let's figure out the distance to our target at any given time. Our distance to the target is the position we want to be at minus our position dot magnitude. So it's the magnitude of the vector pointing from us to where we want to be. So if the distance to the target is less than the arrival distance. Okay, well, thanks for watching. I'm actually going to be, man, this light, my window's shining right on me. Yeah, I'm gonna be wrapping this session in a few minutes anyway. So yeah, for sure. Take care. Nice meeting you. So if the distance to the target is less than the arrival distance, then desired velocity is equals. So we want it to decelerate as we get closer to the target. So this is going to be, let me think. We want to take, if the arrival distance is 0, we want our speed to be 0 effectively. Or if our distance to the target is 0. So we want one minus what did we call that value? Arrival distance. One minus arrival distance over distance to target, I think. So, yeah. If the distance to the target is the arrival distance... Okay, no. I did this backwards. If the distance to the target is equal to the arrival distance, then this is 1. And so we're just multiplying the velocity by 1, which doesn't change it. But then if the distance to the target is half the arrival distance, then this becomes 0.5. Desired velocity becomes 0.5. Okay, cool. Yeah, I think this is right. So this basically means when we come within that arrival bubble, we are going full speed when we're at the outer edge of it, and as we work our way in, we slow down more and more and more and more and more until we get to it or very close to it. Just gonna send a message real quick. All right, let's see if I can finish this before I wrap the session. So we have the distance to target. We decelerate. Decelerate when we're close to the target position. So now we know our desired velocity and we know our current velocity. And we want to apply a force to try to arrive at that. So desired velocity minus the current velocity is the force. We can never let the force be greater than the maximum force. So we clamp the force to the max thrust, and then we're going to apply it to the ship rigid body. So we're going to add force. Times time.delta time, so that it scales with the amount of time that's passed since the previous frame. Let's test this. I didn't set any of the numbers on here. So max velocity, don't know, call it 10. Max thrust, call it 10. Arrival distance, I think this is in units and this is 1 unit, so maybe arrival distance will be like 3 or 4, like half a screen-ish. I'll call it 4. That's less than half a screen, but it's fine. All right. This is working. It's very slowly going in the direction we want. I'm gonna turn off the ship controller here so that it doesn't interfere. And this is working. Look at that. It turns to face in the direction of the mouse and it thrusts in the direction of the mouse. So I'm gonna try increasing the thrust and the max velocity a lot. Maybe up the steering force slightly and the max rotation speed slightly, so this whole thing feels a little snappier. Up the arrival distance to be a little more broad. Let's try this out. Look at that. Look at that. Still very floaty because I got to tune the values, but we are moving towards the mouse now, which is awesome. No longer have to control for sliding and rotation, all that stuff. And we can have thrusters increase the amount of thrust on the ship. We can have deceleration automatically, which is nice. And if I put this way out here, the ship should go faster. Nice. Definitely need to tune these values though. I'm gonna double the max thrust and the max velocity here. So if I just keep my mouse on the asteroid, it should nicely decelerate. Which it kind of does. I think I need to up the arrival distance a little bit. Anyway, this is cool. So this is pretty fun, and I think I just need to tune the values and it could feel pretty good. But that's going to be it for this dev session. So thanks for watching and tuning in and chatting, folks. I will be doing more of this over the long weekend because I'm going to keep cranking on it despite the holiday. But probably won't be back on today. Maybe I'll do like another hour session later this evening. But thanks for watching. Check out our Discord if you haven't. Like I said, it's new.